So, I got a big title there on my slide. I don't know. I'm going to talk about JDI, but the title of my presentation is Precision Forest Inventory and Strategic and Tactical Planning. I'm going to give you a bit of our JDI flavor of it, how we use inventory, how we're trying to leverage the inventory that we have inside of the strategic and tactical planning framework. How do I actually, is this the clicker thing, this thing here? Somebody looking for the big green button? Oh no, that's the other green button, the one with the laser pointing thing on it. Yeah, I got it. Okay, no, I'm rolling here now. I've already wasted 40 seconds. So I'm going to give you a little overview of JDI if you don't know who we are. I'll give you a little bit of an overview of our forest inventory, our approach to GIS, that kind of that world. And I'll talk about forest planning, strategic and tactical planning at JDI, and an engagement we did with Remsoft a few years ago, and how we've been working our way through that over the last few years. I'll wrap it up, and hopefully there's some questions, but it's okay if there isn't. I don't know. Something I've learned since I've been with JDI is put the stuff up front that you really want to impart on people, because a lot of the times I'll give a presentation and we don't get past like slide 2. Somebody interrupts and then the whole thing's in the ditch. And so, really there's four themes I think I wanted to stay in as I gave this talk. The first is what I called precision with purpose. So we have this hyper precision inventory and it's all great. You have to be really smart with how you apply it. You have to try to make an impact where it counts, where it changes your decisions. And I'm going to touch on that a bunch of times. That's probably my most popular theme in the presentation. The others are a little more abstract. We think of our inventory as planning infrastructure. We've got this EFI, Enhanced Forest Inventory, Precision Forest Inventory. I don't know, we call it all these various things. Some folks at JDI just call it the LiDAR. But we think about that as it's the thing that we have that feeds our planning models. It feeds our operations. Everybody has it in their hands at all times, and they're using it for things every single day. For planning, for execution, for everything. So it really is something, it's an infrastructure for us. The third theme there, again, it's a little more abstract, is data decisions, how we leverage that inventory in the planning space. It feeds all of our tools, strategic and tactical models, which is excellent. And then the last one I think is something that everybody thinks about all the time, particularly in this group, is what I call scale without scale up. And really what that is trying to make an impact with a small team or whatever size team you've got, um, through automation and just being intelligent with how you work, right? So JDI, if you don't know who we are, I think that embodies it on the map there. One of the largest land managers, landowners in North America. We manage we manage 6 million acres or so across Maine, New Brunswick, and Nova Scotia. We manage 1 million hectares of crown land in New Brunswick. You can see it highlighted there in the light green on the map. And then our private land, we have a 500,000 hectares, sorry, 1 point whatever it is million acres in Maine. 750,000 hectares in New Brunswick. I'm going to stay in hectares. I'm just like semi-bilingual. 750,000 hectares in Maine and around 50,000 hectares in Nova Scotia, plus or minus on any given day with whatever deals happen to be going on in any given moment. Just to give you we're a big, I don't know, we're a vertically integrated company. We have a big manufacturing footprint. We've been around for something like 140 years. We've owned some of our land for in the 60 or 70 years now at this point. When I say we're vertically integrated, we like to say we're vertically integrated from seed to shelf. We have a nursery, we obviously own land, we have sawmills, we have a pulp mill, we produce cardboard and paper and tissue, trucking companies and packaging and retail and all kinds of things under the sort of JD Irving conglomerate. Just to give you a sense of our manufacturing footprint, we've got 10 sawmills, 2 white pine, 1 hardwood, 1 cedar, 6 softwood sawmills, SFJ sawmills. We have a pellet plant in northern New Brunswick. We have a peat production facility in Juniper in central New Brunswick. We have 2 pulp mills, one our flagship pulp mill in St. John, and we have a smaller pulp mill, hardwood pulp mill in St. George, Lake Utopia area, and we have a paper mill in St. John as well. And then we have 5 tissue, converting facilities around the eastern seaboard. I don't know if I can name them all, but we've got one in Toronto, one in New York, one in Macon, Georgia. We have one in Moncton, and we have one in St. John. I think I got them all. Looking at the map here. 1, 2, 3, 4, 5. Yeah, right. So the Woodlands division, which is where I work, it's a division. Our responsibilities are really the land, managing the land and managing the forest operations, and we're closely integrated with our sawmills division. We have around 2,000 people working in the division, most 400 of which are full time. There's 300 students and 400 sort of partners, contractors, and then 800 or so operators. So 400 full time staff. Woodlands focus full time staff. All right, this is like my cue card to move on from talking about JDI. So digitalization at JDI, I tend to think of it in two buckets. Really, the general theme of it is trying to get better at what we do every day through leveraging technology. For a guy like me who's more focused on planning and land management and strategic and tactical planning and inventory and GIS and all the growth and yield and all those kinds of things, you know, we try to use technology and the digitalization theme to try to better understand the resource, through you know, better data, more timely data, that kind of thing. And then obviously there's this other bucket of just generally becoming more efficient, trying to become more efficient through our digital supply chain, stuff like stem files off the machine head, automation, all that kind of stuff. I don't know. I put this slide together myself. It's unsanctioned, but I like to think, and it's very selfish. We put ourselves at the center here, but I really think that the forest inventory and then our planning system, it really drives the value chain. It's really the heart or the lifeblood of the value chain for the company. For Woodlands in particular, it really sets up our manufacturing and all that kind of stuff. So our goal as an enterprise, as a division, is securing low cost, high quality, expanding, growing wood supply for our manufacturing footprint. While we practice world class environmental stewardship, all that kind of stuff. But you can see, if you're looking at the graphic, the forest inventory really drives all of the processes, right? Strategic planning, it takes out, feeds back in, tactical planning, same thing, blocking, same thing, pulling data out, pushing data back in, budgeting, silviculture, all those things. It really, the inventory, especially in its modern, digital supply chain, digital twin, whatever you want to call it, world, is really the lifeblood of the supply chain or the value chain. I find for guys like us, we have a fairly small team, 4 or 5, 6 guys, depending on, when you're referencing us in time. But demand for insights and all that kind of stuff is higher than ever. We get more questions than ever from everyone, right? Guys in the woods ask us questions now, questions they would have never thought of many years ago, all the way up to the senior leadership team, right through to the owner. They want to know what's going on, what's the strategy, what's the impact of this or that or the other thing, my decisions. Put the thing down. There it is. There we go. So I'm going to talk a little bit about our approach to inventory. I'm probably going to go into it in way too much detail, and I don't know. I find it to be a fascinating space, and you might know a lot of this stuff already. But our approach to inventory is we do these big bulk captures, probably on about an 8 to 10 year cycle. Maybe shorter, maybe a little longer, plus or minus. But we have wall to wall forest inventory that is all LiDAR derived, enhanced forest inventory, if you want to call it that. And we do it on an 8 to 10 year cycle, and we believe it's worth the investment. We're generally, I don't know, we rarely take a year off in the inventory space. Again, I think it's worth the investment because it feeds into our digital supply chain, which we're heavily invested in. So how do we do it? I don't know. I have this slide. There's too many animations on it, but I didn't want to take them out because they were so much work to put in initially. But we fly over the forest with a plane with a laser or with a LiDAR sensor mounted on it. We collect the point cloud. You get the surfaces and the digital surface models and all that kind of stuff. I'm going to skip over most of this because most of the capture work we dabble in it a little bit ourselves, but we mostly pay somebody to do it. We use what's called an area-based approach. So we overlay a 20 by 20 meter grid over top of our forest. We summarize the point cloud with LiDAR statistics for every grid cell. So basically, we put together a data package for every grid cell that describes what's in the point cloud. I don't know. There's 77 statistics if you ask our biometrician or inventory guys. Sometimes there's 90, sometimes there's 200. I don't know. They decide which ones are meaningful. But then we go out on the ground and we measure plots. We use a survey grade GPS, just like anybody would, to get an accurate location. And then, the goal of that is to build a relationship between what's on the ground and, what you see in the point cloud, right? So once you've built that relationship, we use machine learning, AI sort of tools, mostly machine learning, random forest, that kind of tool, those kinds of models to we build those relationships and make the prediction across the resource. So we get this wall to wall coverage of our forest inventory across our managed land and across the province of New Brunswick. We work with the province. I think man is here somewhere. There he is over there. To get wall to wall inventory across the maritime sector really. What our foresters get looks something like this. It's all on a 20 by 20 meter grid. It's very organized. It's a very nice and tidy package. They can see it spatially, they can aggregate it, they can summarize it, what have you. I think the grid is a really powerful data structure. It never moves. This is what we like about it. We used to use stand boundaries and vectors and all this kind of stuff, but I found over time, they wobbled. The vector boundary change, you buffer it or whatever. But with the grid, nothing ever moves. It's a very consistent and high quality data structure. You can pull things out of it with a database as opposed to needing to do spatial jobs all the time, that kind of stuff. I want to talk a little bit about the management of it. It's not purely lidar derived. I think that's a somewhat unfair assessment. It's a blend. We have what we call a precision forest inventory, which is this grid based product, but it's a function of sort of your traditional GIS layers. Where are your conservation areas and your deer yards and your inoperable areas and your buffers and all those kinds of things blended with the lidar derived EFI. And then we take it a step further and we run a tree list imputation process or a nearest neighbor matching process on against a plot database. I think we have a database of like 60 or 70 or 80,000 plots. And so we do a matching process to generate the tree list to parameterize our growth and yield models, so that we can grow the inventory forward through time on whatever scale we're interested in, right? And then we push in updates from the field every day, right? As often as we feel like it, we're collecting updates in the field every day. We use GPS units mounted on our equipment these days to generate our harvest updates, and so that makes that a lot simpler. So that I do some checking. There's still a bit of manual data collection, but it's a whole job to be managing the inventory. So we put a lot of work into it to keep the system up to date. I think it bears fruit in the planning space quite a bit, and so it's an important job that somebody has to do that nobody ever wants to talk about. I think this sets up my next point. I like to think that one of the challenges of working with this data is you really have to manage the resolution. I call it the paradox of enhanced forest inventory. It's really more detail than you need. You've got this hyper precise inventory that describes within stand variability and all the kinds of things that you were after when you flew the lidar. But really, you're still constrained by the tools you have, right? If you're a Woodstock person, you're still trying to fit it in the box, right? You're constrained by your solver and the technology around that. And then your own ability to build something, a model that you can understand. You're not going to run a cell level through Woodstock. It wouldn't mean anything, even if you built something, right? You've got to aggregate something in some way. So I'm going to come back to my theme here: precision with purpose. And so you really have to, for us, we really try to leverage the point cloud and aggregate it in a way that's very meaningful to us. And an example is, oh wait, this is my cue card to jump into planning. But an example for us is in managed wood. Just before I get into this, but I don't know. I put this slide on here as a cue card because now I'm transitioning into the planning space and our approach to planning and deriving the inputs and all that kind of stuff. But again, I feel like this slide is like 30 years old, right? The planning hierarchy is this forestry thing that people have been doing in theory and in practice for as long as there's been planning in an LP world in forestry, or maybe even older than that. But I think it's an old idea, but the better your data is, the better the idea works, right? You've got strategic model, you've got better data, it just makes the thing work better. And I think that's largely been our experience and our approach to all of these things. We're not really in the operational optimization space today, but we're firmly in the top two, strategic and tactical. And I would say, having better data has made those work better in the strategic space. We've been in that for a long time. The tactical space has made it possible, right? So I wanted to put this slide in here. I didn't have it in, and I was like, I need to make sure that I reference this Remsoft engagement that we did a few years ago. So I think it was in 2021 we did this with, of course, 2021 and maybe into 2022. But we did a big engagement with Remsoft in the strategic and tactical modeling space with the focus or the goal of modernizing our planning capabilities to align with our modernized inventory. We got this hyper precise inventory. We wanted to get serious about how we build the model inputs. We wanted to build out an enterprise strategic modeling framework. In the past, in the old days, we'd build models in an ad hoc basis for each district, one district at a time. And if you looked at them one versus the other, they'd be different. And we said to ourselves, well, we should be standardizing this across the piece. Let's, have one modeling framework that we can leverage. If we still want to work on the district by district basis, we can. But, everybody's on equal footing, we're stratifying and all those kinds of things. And then the second piece of that, which at the time, I think, the perspective was, well, this is a bit of a throw in, which has become much more valuable as we go through time, is to build out an enterprise level tactical model. So our approach to strategic planning, you already saw this, but I think it's just a good way to level set. We do an 80-year focus on in our management plan, our strategic planning space, and we put the full land base in there. So everything goes in, right? Typically we'll break up Crown and Freehold because Crown is this, the New Brunswick guys here could relate to the experience of writing a Crown land management plan. It's a whole different thing. But on Freehold, it's fairly clean. Focus of those management plans tends to be more sustainability, you know, areas and volumes, what's my harvest levels, those kinds of things. On Freehold, we delve probably more into silviculture strategies and one of the effective strategies. And lately, we've been branching out into carbon and credit flows and those kinds of things, and bringing that kind of stuff into our wood supply world at the strategic level for projects and those kinds of things. So I'm back to my theme here. So one of the things that we do that is much different than Laura's models and those kinds of things, the AFM folks, is we stratify our land base. In order to parameterize our wood supply models. We don't do stand level models. We build big strata level models. We roll up the forest, we aggregate things. In the past, that would have been a function of, well, the land, there's so much land, so much area, would have done ground plots to build inventory, to build yield curves and all those kinds of things. Now with LiDAR, it's a much different focus. You've got, all this ability to understand, stuff that's going on within the stand, right? And so when I say, precision with purpose and leveraging the precision where it counts, our focus is on management. So I got an example up here. It's a spruce plantation. I'm not going to give you the location because that would reveal too many secrets. But but you can clearly see, it's a canopy height model. What you see up there on the screen, you can clearly see the front half of it looks pretty good, right? You can see lots of stuff going on there. The darker green means more trees, bigger trees, taller trees, whatever. Everybody can see that. The back half is sparse, right? You're having trouble there. You can stratify those two things out. And when you're building out your wood supply model, because now it exists. Before, you would have just been all lost in the average in the old days, right? The average volume for this block, say 80 cubic meters to the hectare at whatever age it is, whatever this capture was. In the front section is 120 cubic meters a hectare. I'm going to say the back's like 30 or 40, right? Or less. Maybe there's no merchantable volume there at all. And so you can manage those two things differently and put them on one, the back half, you might just reset. You say, well, there's nothing here. We need to reset the world here. Maybe we need to take it out because the ground's no good or whatever. But you can have a conscious thought about what it is we're trying to do, both halves of this, because it's really become two separate stands, right? And so when we're building out our stratification for the inputs to our strategic model, what you see from a wood supply input perspective is something like that, right? Okay, we built the front half, it's set up on a yield curve, and the back half is set up on a different yield curve so that it can have a different level of decision making applied against it. I'm making a quick aside on growth and yield. I'm not a growth and yield guy, but I feel like this, just to justify, the whole existence of the LiDAR space. Once you start to get into this multiple capture LiDAR, you've flown land bases multiple times. If you're a landowner and your land base is fairly consistent, you end up in this world where you've done this repeated capture across your land. And there are novel opportunities for growth and yield model development. And we've gone down this road quite deeply in order to, whatever, build site index based, stand level, block level, tree level growth and yield models, because you're really measuring growth at an unprecedented scale. We think of it as a census as opposed to just a sample. Historically for folks like us, growth models were developed by, repeated measures on plots done over many, 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 many years, right? Many measurements, all those kinds of things. But now your framing is different. You're not getting 40 years worth of measurement, but you're getting a measurement on a massive scale, right? You're getting your million or half a million or whatever your land base size is, hectares worth of growth, right? And you've got accuracy issues on the lidar, but certain things like height, or I mean, that's what the lidar does best, measures how tall stuff is. So you can really dig into increment on a height basis. Anyway, that's my growth and yield aside. That's my transition here to tactical planning too. So tactical planning, like I said, we built this tactical planning model with Remsoft. It's a 5 to 10 year model. The land base is really the blocked forest. And in my view, there's two interesting things in this space for us. One is how we build blocks. I don't know how everyone else here builds their harvest blocks, but historically it was an extremely time consuming job, right? You're drawing boundaries, you're printing out your maps and you're laying them on the table, and you get the grease pencil out or whatever, and you're drawing your blocks, and then you're handing them back and somebody's digitizing them for you, or maybe you're doing it in a web app, but it was a manual job, right? Anyway, and then the other one is the tactical modeling space as a whole, once you figured out the blocking picture. So the focus of our solution was really harvest scheduling, at the prescription, balancing that to mill demand and wood flow while considering costs and procurement and capacity and all those kinds of things. But really the model is driven by demand and wood flow, right? And then it schedules things to meet demand based on inputs from the strategic planning process, right? Your ACs and all that kind of stuff, silviculture. So we think of it as this end-to-end optimized digital forest supply chain. I don't know, I put this graphic in there because everybody really likes it for one, and it takes a long time to make. And you're like, well, I better use this, get some value out of it. But I can really just skip over it. I wanted to talk a little bit about Woodstock and what modules we're using, because I had nothing in here about Woodstock anywhere, and I was like the last minute scrambling to put some stuff in. So just to give you a bit of a checklist, we're using Integrator, we're using AO, we're using the Roads tool, which has been a very powerful thing for us. We're obviously using Woodstock, and then we're leveraging the database and ETL functionality through Integrator to turn over this tactical model and the strategic model, but more so in the tactical space. It's a super structured approach, but it's been very, very effective for us. Once you've built out the jig, you can turn the thing over very quickly. It makes that work a lot easier. Again, I think about the old days and trying to turn your model over. It was a ton of work. Oh my God. Okay, I want to talk a little bit about auto blocking. And so we have this process. We've generated this GIS process. Imagine a world where you've got this grid-based inventory, and you're like, okay, I know how much volume and what the current state of every single cell is on my land base on a 20 by 20 meter grid across the whole piece. You know something about stand boundaries and all this kind of stuff. So I think our theory was, and this idea predates me, but we fine-tuned it quite a bit over the last couple of years in order to better fit into the tactical planning space. So we've got multiple years of operability. We've got wood coming online in the thing now. But anyway, it's a much different world that we're living in now than we were when we originally developed this concept. But if you've got a 20 by 20 meter grid, you know something about every single cell on the land base, you can run some kind of cell aggregation routine or a cell aggregation routine that builds out, harvest units, right? Based on business rules, your operability rules, similar to what you'd use in your action sections or whatever in your strategic model or your tactical model or whatever, wherever you're imposing operability. And so when I say precision with purpose, we're really trying to aggregate, the 20 by 20 meter grid here into operable harvest units. We're leveraging our enhanced growth model capabilities that we've developed over the last few years, all to push that into the tactical modeling space so we can really extract the maximum value from that solution. And anyway, what you end up with is something like this, this sort of block here. You play that out over across the whole land base and you get all the blocks, right? This is what our operable wood looks like over the next, whatever the time frame is you happen to be interested in. We tend to focus on a 10-year period. Sometimes we go a little more, sometimes we go a little less. If you want to go more in the tactical modeling space, you've got to give up on some stuff, or you maybe do some additional aggregation. Remsoft helped us build a clustering tool or an aggregation tool that groups blocks up based on block type and prescription and all those kinds of things to help make the decision making quicker. That's been a tool that's been very effective for us, because when we told them we wanted to put in like 70,000 blocks in a MIP model, they were like, I don't think that's a good idea. You need to do something else. Anyway, you can get a feel for what the land base looks like a little bit there, and some of the block type and prescriptions. I wanted to put a little bit of a slide on the roads tool in here just to give it a bit of a plug, because again, we've extracted a lot of value out of this tool. What are we using it for? We really leverage it with our road network, which again, we spend a lot of time managing a road network. It's unbelievable, how many kilometers of roads that we manage or that exist in our database, and how many routing options are available on a block level or a cluster level. And so we leverage this tool to generate our origin to destination matrix, right? It takes every block and it says, okay, what's the best route to get from this block to all the potential destinations? And so it builds out that matrix so that when you push it into a tactical modeling framework, it's got what it needs to decide on from a wood flow perspective. Where should the wood be going here? And we also use the road maintenance constraints to promote clustering of harvest blocks. I wouldn't say that has made a huge impact for us. It does something, but I find that our value chain is so complex. We've got so many products, so many customers, so many destinations, so many different species. We have a very diverse forest in the region that it's a really difficult problem to solve. And so you'd think you'd get all this clustering, everything groups up together, but at the end of the day, it turns out the problem's so hard to solve that the model has to reach out and get stuff. You get these co-production issues, is what we used to call it in the, I'm thinking about Andrew Cogswell and co-production here. Anyway, you get something like this. This is just a draft or whatever of one of our harvest schedules, but just to give you a feel, it's all spatial. So everything we look at is spatial. Nothing is aspatial. And so when we hand something off to a forester, we're like, well, here's the map. And they look at it and go, okay, I got to zoom out a little bit here and decide whether or not this is reasonable. Um, because again, I'll say something about a tactical solution. It's not an annual operating plan. It doesn't generate an annual operating plan. That's a different thing, right? It's got access and culverts and bridges and road maintenance and grading and brushing and all the kinds of stuff you need to do to get a block execution ready. That's really firmly in the annual and the quarterly sort of planning space. We tend to stick, you got to zoom out a bit when you're looking at a tactical plan. For us, you got to say, okay, if I zoom out to whatever 1 to 100 whatever thousand, and you're picking a random map scale. We should have put the scale on here as a cue card for myself, but I didn't. But then you can start to get a feel for how are we going to operate these sectors. And I really frame this as a strategic operating plan. And so that's, how, we encourage the guys to think about it. This is your strategic operating plan, and you should think about what the best strategy is to get after the wood here. I put this in here because, especially in the tactical planning space for us, it's a full new space. We never had a tactical model before. And, the model and the technical bits are really the easy part, I found for us. We're technical guys. We're a small team in Fredericton. We know data and models and GIS and tools and automation and all that kind of stuff. That's been sort of the easy part for us. The people side's been really difficult, really challenging. People and processes and all that kind of stuff's been the hardest to change. Building the trust, baseline trust in the output, in the model, in the technology, that's been harder. Up and down the org chart, if you want to think of it that way, right? So, I put that we're working against the way we've always done it. And I think that's true. Again, up and down the org chart, you're arguing with guys that are your boss, and you're arguing with, guys in the field who know better and on some level than you, absolutely know way better. Right. So let's wrap it up. Perfect. I'm right on time here too. 20 minutes and 29 minutes and 45 seconds. Takeaways. So, I think we got more stable and defensible solutions than ever. Our AAC is, really high quality. We're able to leverage within stand precision in a meaningful way. We really understand the variability and tighten the variability within our stratification processes better than we ever have. We really scaled tactical planning via our auto blocks process and pairing that up with our tactical model. I think we've created a world in which we've got precision that's somewhat operationally usable. Like I said, it's not an annual operating plan. And I think we've harnessed the resolution of our inventory in a way that allows us to really drive our decision making. And then, trust is hard to come by out there in the field. That's real where the real work is. If you're a computer guy and you're like, well, I don't really want to talk to people every single day. And so, it takes a lot to go out there and say, well, here's the new solution. Let's sit down and look at it together and, build something out, right? Anyway, just got another slide here, but AAC, better AAC confidence, better block definition, cost optimization. We've really shortened our planning cycles. That's one thing with putting all this effort into managing our inventory has really hit home for everyone. You can turn out a management plan if there's no, let's just say, BS involved, in a pretty short time period, right? And the last one really is we don't have a huge team. We and our portfolio is fairly broad. We do me and like five guys manage the inventory, the GIS, the growth and yield, all the wood supply, and all the operational tools that folks use in the field to help plan the execution of their blocks. And so, through automation and a little bit of creativity, I feel like we punch above our weight within the enterprise. And so we've been able to scale ourselves pretty well. I expect that AI and that kind of stuff is really going to help us push further in that direction. Um, yeah. I put this slide in here, which is, I think, a good one. Better inventory, better story. We've leveraged it in all kinds of ways, right? Reporting, carbon. We're our value chains carbon neutral. We've got carbon neutrality labels on our tissue products. And so, I think that's a better data, better story. That's it. Thank you.
Increase in precision or resolution stratification increases the size of the models you're using for strategic or tactical plan.
Increase the size of the models. Yeah, but I think our whole goal is really to try to manage it. When I say managing resolution, precision with purpose, and you're constrained by what the technology is capable of, right? You're trying to build something that performs in a way that is up to your expectations. And so we spend a lot of time and effort on the stratification process in our strategic planning world, and then in the blocking and the grouping of blocks through the Remsoft tool in order to manage the performance and size of the models themselves. And so it doesn't increase the size, yes, but we're hyper aware of the size of them and the performance. And, we're really driven by keeping that within reason. Yeah. Go ahead, Doug.
Hello, Grant.
Hey.
Great presentation. Thank you. I got two questions, but I'll give you the first one and then see if someone else has another question. Um, I'm a big proponent of tactical planning
Hmm.
for lots of reasons. And one of the things that one of the values of the tactical plan is that you do get a spatial schedule that's aligned that helps you set that path forward in the business.
Mm-hmm.
Um, there's a I like the way you said it. It's a strategic operational plan. I think that's what you said.
Mm-hmm. Strategic operating plan.
It,
Yeah.
it gives you an option, right? It
Yep.
doesn't mean it's right. It doesn't mean it's going to be operationally feasible. So one of the things is like, okay, the schedule's one output that gives you some guidance. Great.
Mm-hmm.
But the other part is a tactical plan, and it's part of that decision matrix you were showing there. It gets to help you make better decisions.
Mm-hmm.
Can you point to anything in your experience where you're using the tactical plan for helping make better decisions in your business maybe across different functions in the business, whether it's the sawmills or whether it's the woodlands or whether it's executive
Yeah.
questions? Can you
Yeah.
point to a couple of
So,
those?
so I guess I think of the output. So the actual, if you take the model output, having the downstream transparency, just like better planning makes everyone's lives a lot easier. You've got more visibility as a downstream customer. And we've got guys that are operations experts, really smart guys, St. John guys that can say, all right, here's the 5-year plan, something they've never seen before, and you can say, well, this is, if you frame it as a strategic operating plan, you say, well, what's the right strategy to operate this plan? What can we do to bring the cost down of this picture, right? Should we build a road through here because there's going to be all this fiber flowing in that direction? Like having that visibility to our downstream customers and the leadership team is really, I think, where the value is there. And then the sawmills, the same sort of thing. Now they've got a, I mean, they always just expect that the wood's going to be there, but now they've got a clean picture that says, well, yeah, the wood's definitely going to be there. What does the profile of that wood look like? And now you can work on solving some of the, I'm not going to say smaller problems, but harder to solve problems like, well, where are my logs coming from? And is that going to be taken care of in here? I know the model says it, but like, anyway, it sets up all the downstream stuff very well. Could you get into an operational optimization space? Perhaps, but certainly today, having that visibility for all of our smart guys in St. John that think about, well, what's the strategy to operate this plan is huge. And for our mills, yeah.
Does anybody else have a question? Okay, I'll let that.
I should say that it does do the chip flows too. There's a little plug there for it does have multiple tiers of destinations and interim destinations and all that stuff. Yeah.
Hi, Brendan Moore with the Lime Timber Company.
Hey.
Great presentation. I like that slide where you had the spruce plantation, and I think maybe that was like your original stand boundary
It was, yeah.
around that, and then you I think you split that into maybe 3 or 4 strata.
Yeah.
That are informing your model.
I think the final version of that would have been 2. If I'm just using
Okay,
I'm looking
okay.
at that going, that's 2. That's 2 things, not 4. But
And
yeah.
and so my question is, there seems to be is there a disconnect between your model strata and then your 20-meter grid that goes into the auto blocking for harvest planning?
What do you mean?
So why are you not doing your harvest schedule based on strata? It seems like you're modeling on strata and then doing the auto blocking based on the 20-meter grid. I'm just curious, why is that? Why is there a disconnect? If there
I
is.
wouldn't say there is a disconnect. If I argued about it, I would say, well, they're derived from the same thing. The strata is just a means to fit something into a strategic wood supply model, but ultimately it's derived from the underlying inventory, just like the auto blocks are. They're just 2 forms of stratification with the same underlying, their same underlying inventory. Could do a blocking plan with the strata? Yeah, I think you could. Um, uh, we tend to frame up our blocks that from a prescription perspective, which really relates back to typing, right? Stand typing or what have you. And so it is connected to the strata, you know, through these sort of nuanced things. Plus, you've got the underlying fundamentals of the inventory that drive that blocking process. So, I think I would argue that they are connected. But if you did want to believe that they were disconnected, you could do the job in, say, like a Stanley or a spatial optimizer or whatever, just to give yourself a gut check on, how well are we doing here? Yeah.
I have a related question to that. 'Cause I'm curious. So as foresters, we're all fixated on stands. We've always been so stand oriented. And now with the EFI, in terms of the process you're going through, that stand boundary is kind of gone. There's no longer stands. They're kind of there, but they're kind of not.
Mm-hmm.
But when you look at that block, the example, you've really created 2 distinct units in there now.
Mm-hmm.
So that's a big change. And now you're managing it at a smaller scale, at an area level.
Mm-hmm.
How has that been a challenge to the team in terms of operating on smaller levels now?
Mm-hmm.
When you have a big company with lots of scale, and are you seeing differences on the ground? Like, are we managing more micro now? Is it making a difference? I guess is what I'm asking.
Yeah, that's a good question. Do we manage smaller units now than ever? Yeah, perhaps. I still think that you've got minimum constraints you're trying to work with there, operational constraints, right? Like you're not going to go after a tiny little whatever, right? A cell or an acre or whatever. You're going to try to group that up, or we used to use fragmentation analysis and those kinds of things to use a Woodstock thing if you wanted to get into that kind of stuff. But I don't think we've really run into that problem. It really just helps get everybody on the same page in terms of what's possible. That's why I say it really fine tunes your AAC. Now your AAC is fairly dialed in, and it's based on something that's a little bit more, let's just call it real. It's not perfect inventory that I think Ray, or if he's Ray's in the room here, was looking for, but it's better than ever. And I forget the second half of your question, Doug, because I got caught up in the first half there. Right. Yep. 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 Yes. So I think the short answer to that question is yes, we are seeing that because, with that kind of visibility on the land, not that the guys out there don't know that already because they spend their time in the woods and they know their land bases, and our foresters manage big land bases, right? Like that would be somewhere in a 300,000 hectare land base that like one guy or a couple guys are in charge of, right? But so they know their land, but it brings that stuff to the forefront, and so they can change the way they think and operate. And again, yes, so I think it would show up in your ACs and that kind of stuff in the future. Yeah.
Excellent. Does anyone else have any questions?
Good. Thank you. Oh, one more. Oh, sorry. Yeah.
Sorry about that. That's great presentation. And I feel guilty not letting you get off the stage.
No, it's okay. Yeah.
My
This is
question
the
was,
easy part.
my question was just if you could comment um, species aggregation and the level of detail that's in your process from generating the yield curves to
Mhm.
making decisions, about mill supply, and other places where that individual species level detail really comes into play. And
Mhm.
so one of those would be like carbon metrics as well.
Sure. Yeah.
So I was just wondering if you could broadly comment on how that
I don't know
works.
that the species problem's been fully solved. Um, from a LiDAR perspective, I don't think, that's really been tackled. We still use imagery to get there as best we can. We're working on new methodologies to kind of come up with what that typing picture looks like from an individual species through, more things like Sentinel or better, right? That kind of remote sensing type or, satellite derived imagery. Um, Today, we still benefit a little bit from some old photo interp. We still buy it occasionally just to get ourselves square. It's becoming less of an issue for us as one of the things that we're trying to do on our land is get it more organized, and so get a little bit intense, especially on our private land. And as you become more intense, the species question starts to cancel itself out because you were there, right? You were there, you put the trees on the ground, you know what they were, you know what the genetics are. And those questions you're like, well, why are we still working on the species thing? Where we still got more natural wood. We're working our way through that. We've got typing, and we find it can work. It works for us. We know how to work with it in order to get something meaningful out of it. And so we'll when we're doing plot matching, say, we do this plot matching thing, this nearest neighbor tree list imputation thing. We factor in a combination of the traditional stuff, the typing associated with interpretation or whatever the best source is we've got, um, alongside the LiDAR metrics, your EFI derived metrics. And so when we're coming up with a tree list so that we can grow it forward, we're balancing that. And so we're trying to make sure that the typing that's associated with the tree list that we ultimately get from our giant database of plots they're aligned. And so when we're projecting that forward either for volume or, into the CBM, CFS3 or whatever we're trying to do. Um, we find that the typing is in line. Yeah. So species, it's still a challenge, but I think we've got ways to deal with it today. And there's certainly room to grow. Yeah.
Still part art, not all science.
Yep. Yeah, absolutely. I wouldn't say that nut's been cracked. It's still in the research stage. There's options out there, but I don't think we've got to a place where any of them work the way we'd like it to work quite yet.